In this example, we want to design a counter using a synchronous binary counter, which is shown, and one AND gate. And we want to have the sequence of the numbers starting from 0, 0, 0, 0 through 0, 1, 0, 1. So if I write down the numbers that we are going to have, they will be in this form: 0, 0, 0, then 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, and then we need to go back to 0, 0, 0. So one way of doing it is to detect the occurrence of 0, 1, 0, and once it is the case, we can load the counter using with 0, 0, 0 in it. Yeah? How can we detect the occurrence of this number? We can see that by looking at it, we can see that it happens when we have, this is indeed Q2 and Q0. When we have Q2 and Q0 equal to 1, whenever this happens, it means that we have this count value. So I can just place an OR AND gate here, connect its input to Q0 and Q2, and whenever we have that case, we just load the counter. Which value do we use for loading? We use just these zeros. So if we load the counter with the values of 0, 0, 0, then each time that we have this count value detected, 0, 1, 0, 1, the next value will be 0, 0, 0, 0. So we will go through 0, 1, 2, 3, 4, 5, and then back to 0 using the standard synchronous binary counter and one AND gate. So you can see that it is quite simple to do that.